In this session we're gonna implement a simple game server based on Scala together with Akka HTTP, Akka streams and Websockets. So let's see how it's going to look at the end. We're running a server first, and as we can see it is up on port 8080. Let's run the first client. We need to provide our player name, and as we can see the client connected to the server, and we get a simple view like this where we can move around. Let's run another client, and another client is connected. So this is our goal, and at the end of this session this is what we're gonna get. So let's not waste any more time and dive right into code. So here we are in empty IntelliJ project, just a simple SBT template. And the first thing we're gonna do is modify build SBT. We're gonna add some dependencies. So first, of course, we're gonna need Akka streams and its test kit. Also Akka HTTP core and its test kit. We're gonna also need spray JSON for JSON marshalling. And we're gonna be developing this project in TDD manner, so we're gonna also need a Scala test framework. Let's first create our test. We're gonna call it probably something like server test. Yes, add to git. And for that we're gonna use just a simple Scala test fun suite together with matchers. Okay, and let's see if it passes. This is just a basic smoke test to check if our dependencies are in correct version. As we can see, it passes. Alright, but there's a better way to run tests in SBT project. We can open our terminal window. I configure it to stay on the left side. Normally I would pop up a standalone terminal and move it to another screen, but in this presentation I'm going only one screen, so we're gonna split the view into terminal window and project. And if we open SBT and run a test quick command together with this sign, this means that whenever some files changes, the tests are going to be run, but only the tests that have been affected by the change. So let's run it. It compiles the sources. And as we can see, the tests were run and they pass. To verify that it works correctly, let's do a simple assertion. Save the file, and as we can see, it detected the change, compiled the sources, and the tests are failing. Huge props to people who created SBT, because this is really awesome feature. Alright, let's actually do something useful and create an empty game service that will handle our connections. Obviously this class does not yet exist, so let's create it for the sake of this tutorial in same file. Let's see if that passes. Yes, it passes. Awesome. And let's create another test. Should be able to connect to the game service Websocket. Yes. And if you look at the documentation of Akka HTTP together with WebSockets, we can see that in order to establish WebSocket connection, we need a simple Akka HTTP route together with handle WebSocket messages method, which takes a flow that takes message, outputs message, and materializes to anything. Materialization is a process of running a closed shape. Here we have a flow, so on both sides it is open. So once we close it with the source on the left side and the sink on the right side and run it, then we can say that the stream is materialized and there is emitted a materialized value. Let's copy that and paste it to our service. Good old copy paste developments and import dependencies. Yes, fascinating. We're not gonna use any path. We will just expose it under the root. And for this to work, we also need to inherit from directive straight, I believe. Yes. Let's reformat this. And I think we also need, like in every Akka-based application, actor system. And in Akka streams-based application, we also need something called actor materializer. All right. What this actually do is used by, for example, consuming the stream. So as you can see, if you look at the documentation, this requires sync and implicit materializer. And I believe that we should be able to now test it. To test it, we just copy this example. And what it actually does, it's create an WebSocket client and test if the connection is actually a WebSocket. For this test, we also need to extend from Scala test, root test, yes, this one. Okay. And I believe it should now pass. Compiling, yes. Next test is going to check whether the WebSocket responds with correct message. And we can use our probe to send message, and it's going to be a text message containing text hello. And on the server side, let's just respond with the same message the server receives. So we don't need map concat, we just need maybe a collect. And it will return just the same message it received. So we can simplify like this. So when the server receives a strict message with text, it responds with text message. So we're sending message called hello, and we expect message which is the same. Let's see if that passes. Oh, we need to just send. It will wrap this in text message. Okay. Now it should be passing, and indeed this passes. So what we have now is a server that accepts messages and just responds with the same message it received. So far we can connect to the WebSocket, send messages and receive them. Let's implement a simple way to register player. So should register player. And there are few ways to do that. We could, for example, send message to the server, say with something like register Andrew, but there's actually a better way. And from the client side, we expect to get immediately message from the server without notifying it with any message. Welcome player. Or maybe yeah, player. But if we don't send any message, how come the server knows that we are connected? Well, because this is a flow. So a materialization is just a process of allocating all required resources for running our graph. What we are doing here is defining just a flow, so a kind of a graph that has both ends open, and once the Akka connects it to the sink at source, so to the client and server, then the materialization process begins and the materialized value is emitted. So to achieve it, we need a slightly different approach. We have to create our own graph. We can do it like this. Flow from graph DSL create. And what this method gives us is an builder, and what it allows us to do is add simple building blocks like merge, flow, sink, source to our graph. And let's think for a bit, how can we get a materialized value from within the flow? So materialization, there is actually a method on the builder helper called materialized value, and with import graph DSL implicits, we can also map it to any value we want. So let's materialize it exactly to the message we expected in our test. Welcome player. We still want to handle just a regular message receiving and sending. So we also have to implement this message passing flow. And we did this like this by using an add method on the builder. And here we can provide a flow which takes messages and responds with same message. Because we have two inputs to this graph, which is materialization and messages, we need to merge them. Builder add merge, and we specified that this particular merge is going to have two inlets, where inlet is just an port for the message. all we have to do now is connect this all together. So we have materialization, which result value should be sent to merge at port 0, and merge should send its message to message passing flow. Now all you have to do is define flow shape. The flow shape takes inlet. Here we can use a merge second port. So this port is responsible for taking messages from the client, and it passes it to the message passing flow. So on the output we have a message passing flow out. And that should do it. And as we can see, should register player passes, but the should respond with correct message failed. Why? Well, because now we have a message that is sent to the client regardless of messages the client sent. So if we add this line, I believe it should pass. And indeed it passes.